Okay, we're on to the last part of the circular functions basic videos. Now we were looking at evaluating exact values of angles and their ratios, sine, cos, and tan, across the four quadrants of the unit circle. Right, so we had a look at these three examples in the previous video, and the last example in that is to find the value for tan 52 pi on 6. So let's talk about tan 52 pi on 6. Right, to start with, right, 6 goes into 52 8 times, right, so which means we're going to have 8 times pi with the remainder of 4, right, with the remainder of 4, which means we're going to have 4 pi on 6. Now when it comes to tan, right, every pi rotation we go back to the value in the first quadrant, right, so which means what we can do is we can neglect the 8 pi and just focus on 4 pi on 6, which in its simplified form is going to be 2 pi on 3. And 2 pi on 3 is an angle in the second quadrant because it's a value that's slightly less than pi. Right? So the way I'm going to relate it back to the first quadrant is by going pi minus pi on 3, and in the second quadrant the tangent ratio is negative, right? So which means the answer is going to be negative tan pi on 3, and tan pi on 3 is going to be equal to minus square root 3, right? And that completes finding exact values by relating it back to the first quadrant. Now another way of asking the same question is by giving a statement like this. So here they've given us cos of an angle x is equal to minus cos pi on 6, and the information they've given us about x is an angle between pi and 3 pi on 2, or in other words x is an angle in the third quadrant of the unit circle. Now the way we relate an angle in the third quadrant is by going pi plus theta. Right? Now in this statement what they've given us here is they've given us the angle that they're relating back to the first quadrant, which is pi on 6, which is nothing but 30 degrees, isn't it? So in other words, x is going to be equal to pi plus pi on 6, which is going to be pi plus pi on 6, which simplifies as x is equal to 7 pi on 6, right? And that is the angle x that they're asking us to find, which belongs to the third quadrant. Right, moving on. We're talking about complementary relationship, right? So complementary relationships, complementary angles are angles that add up to 90 degrees. So the first part of it is we're going to have a look at two angles that add up to 90 degrees. Now if we go back to the unit circle and let's have a look at this triangle here, right? Now the triangle, this angle inside the triangle is equal to theta, right? So which means the remaining angle in that triangle is going to be pi on 2 minus theta, right? Let me just explain to you how I got that, right? The total angle inside the triangle is equal to 180 degrees, right? And there is a right angle inside, so which means removing the right angle, there are two angles which add up to 90 degrees, which is what we represent as complementary angles. So if one angle is theta, the other angle is going to be 90 minus theta, or in other words pi on 2 minus theta, right? So if I take into account that triangle there again, I'm just going to draw that outside so we can see what's going on, right? My angle here is theta, the angle here is pi on 2 minus theta. Now in this example they've used alphabets A and B, so I'm just going to continue using that. If I apply SOHCAHTOA to this triangle and I use pi on 2 minus theta as an angle, sine of pi on 2 minus theta is going to be equal to A divided by 1. But what is A? A is basically the x coordinate of that particular point, right? Which is nothing but cos theta in our first quadrant, right? So the sine of the complementary angle is equal to cos theta, and similarly the cos of the complementary angle is equal to sine theta, right? These are the two most important things we need to remember, right? Once we know these two, so sine of the complementary angle is equal to cos theta, cos of the complementary angle is equal to sine theta, right? Once we know this relationship, we can basically figure out the following relationship. right? Pi on 2 plus theta. Pi on 2 plus theta is an angle in the second quadrant, right? Pi on 2 plus theta is an angle in the second quadrant, and the angle and the only ratio that is positive in the second quadrant is sine ratio. So therefore, the answer for this is going to be positive. So it's going to follow the same pattern. Sine of that angle is going to be equal to cos. So therefore, it's going to be equal to a positive cos theta. Right? Now, cos of an angle in the second quadrant. In the second quadrant, cos is negative, right? So cos of the complementary angle is equal to sine theta. But because it's in the second quadrant, it's going to be equal to a minus sine theta. Right? We can write similar relationships for the third and the fourth quadrant. Right? For example, let's take sine of 3 pi on 2 minus theta. Alright, so 3 pi on 2. So that's 0, that's pi on 2, that's pi. That's 3 pi on 2 and 2 pi. Right, 3 pi on 2 minus theta gets me to the third quadrant. Right, and in the third quadrant, the only ratio that is positive is 10. Right, so the answer for this is going to be equal to minus cos theta. Right? Similarly, if I go cos of 3 pi on 2 minus theta, right? Again, in the third quadrant, the only ratio that is positive is 10. So therefore, the answer for this is going to be negative, and the complement is going to be sine theta. Right? The same relationship is also true. The same relationship is also true for the fourth quadrant, right? So if I take into account the fourth quadrant, I'm going to have sine of 3 pi on 2 plus theta, right? So which means in this direction, plus theta, which takes me to the fourth quadrant, right? And in the fourth quadrant, the only ratio that is positive is cos, right? So therefore, sine is going to be negative. So I'm going to have minus of cos theta. And finally, the last relationship is for cos 3 pi on 2 plus theta. Fourth quadrant, cos is positive, therefore the answer is going to be just equal to sine theta. Just going to go back and fix this. Right, so that's the relationship for complementary relationship, right, when it comes to sine and cos. Same can be done for tan as well. So if I take into account, let's take, for example, I'm just going to check if there's an example there. No, alright. Let's have a look at, let's say I have tan 3 pi on 2 plus theta. Alright, so if I want to find the answer for tan 3 pi on 2 plus theta, right, and so the first step here is tan is equal to sine over cos, right, so sine 3 pi on 2 plus theta divided by cos 3 pi on 2 plus theta, right? So now we're going to deal with sine and cos individually, right? 3 pi on 2 plus theta is an angle in the fourth quadrant, and sine is negative in the fourth quadrant, so that's going to be equal to minus cos theta, and cos 3 pi on 2 plus theta, fourth quadrant, cos is positive, so therefore that answer is going to be equal to sine theta. Now I just want to point out one more thing, right? This is something you don't need to know, but it's good to know, right? Now tan is equal to sine on cos. Cos theta over sine theta can also be represented by another ratio called cot theta, or you can also represent it as 1 over tan theta. Basically, it's a reciprocal of tan theta. So if I want to complete this question, I can just leave the answer like this, or I can write it in the form of minus cot theta or minus 1 over tan theta. Right, now let's go back to this example here. So in this question they've said sine theta is equal to 0.3 and cos of that symbol is equal to 0.8. Now they're asking us to find the answers for the two things. Right, sine of pi on 2 minus that symbol, right, an angle in the first quadrant, right, so applying the complementary relationship, that's going to be same as cos of that symbol, and cos of that symbol is equal to 0.8, so which means the answer to this question is going to be equal to 0.8. right? In the second example, I have cos of pi on 2 plus theta, right? Cos of pi on 2 plus theta, second quadrant. Sine is positive, cos is negative. So therefore, this is going to be just equal to negative of sine theta. So that's going to be equal to negative 0.3. And that completes that question there. Right, last and not the least, Pythagoras identity, right? Now, again, going back to the unit circle, right? So we have a point P on the circumference of the unit circle. Cos is the x-coordinate, sine is the y-coordinate. If I apply my Pythagoras theorem to this particular question, my Pythagoras theorem is a squared plus b squared is equal to c squared, right? Let's just consider this is a, this is b, right? And c is the hypotenuse. So if I apply my Pythagoras theorem to this particular question, all I'm going to get is I'm going to get cos squared theta plus sine squared theta equals 1 squared, which is what we talk to be as the Pythagoras identity. So cos squared theta plus sine squared theta is equal to. Now, what do we use the Pythagoras identity for? We can use the Pythagoras identity if the question's given us the value for sine theta and they're asking us to find the value for cos theta. Alright, so this is not a complementary relationship. This is basically sine theta and cos theta. So in that scenario, we're going to apply the Pythagoras identity. So I'm going to write it down first. So cos squared, I'm going to represent it in the form of x in this question. So cos squared x plus sine squared x is equal to 1. Now they've given us the value for sine x, right? So they've given us the value for sine x. Equals 1. So I'm going to substitute the value for sine x. So I'm going to have cos, bear with me, cos squared x plus 3 on 5 to the power of 2 equals 1, which means cos squared x plus 9 on 25 equals 1. Right, going forward, cos squared x equals 1 minus 9 on 25. Right, simplifying that fraction, cos squared x is equal to 16 over 25. Right, to find the value for cos x, I've got to take a square root on both sides. So if I take a square root on both sides, cos x is going to be equal to a plus or minus 4 over 5. Right, so I've got two answers for cos x and I've got to decide which one I'm going to use for this question. Right, so I'm going to go back to the question again, right, and look at the value for x. What is x? X is an angle in the second quadrant, right, and the only ratio that is positive in the second quadrant is sine. So which means the correct answer for cos x in this case is going to be equal to a negative 4 over 5, right, and that completes part A of that question. Right, part B of the question wants us to find the value for tan x, right, and tan x is going to be equal to sine x over cos x. So if I apply the two ratios in there, basically I'm going to have 3 on 5 divided by a negative 4 on 5, right? When you have one fraction divided by the other, you can basically flip the second one and multiply, right? 5 goes into itself once, right, which means the value for tan x is going to be equal to a negative 3 on 4. Right, that completes our lesson on the basics of circular functions. Thank you for watching. Have a lovely day.